if neither the A values or the B values are opposites of each other, or are the same. Remember, that's the thing we're looking for. We're looking for opposites. If they're not opposites, then we have the situation where they were the same. Either the A's were exactly the same or the B's were exactly the same. But what if neither situation is there? What if they're not opposites of each other to start with, nor are they the same? A's are not the same as each other, or the B's aren't the same. Then what are we going to do? We're going to rename one of them by multiplying to create Brighton? Opposites. We're still going to have that same frame of mind. I said it a little bit ago. I said we have to keep saying to ourselves, we need either opposites, A values, or opposite B values. We have to have that before we can add them together. No matter what it's going to take us to get them, we're going to make it happen. So now we have our system of equations here. 3x plus 6y equals 12. Negative x plus 3y equals 6. Okay, so do we have the same A value or opposite A values or opposite B values right now? No. Do we have the same A values or the same B values? No. So you know what? Maybe we should do this. Maybe this will help us out. Let's put A equals 3 for the first one and B equals 6. And right below that, we'll put the A value for the second equation. What's the A value for the second equation? Negative 1. And what's the B value for the second equation?
3.
3. Okay. Well, 3 and negative 1 are not opposites, nor are they the same. 6 and 3, they're not opposites, nor are they the same. So Trey, you have a suggestion here?
Multiply 3 by -2.
Multiply 3 by -2. Okay, that's one of our choices. So you want to take which equation would you multiply by -2? The second equation, because if we multiply the second equation by a -2, we could create a -6 here, and then we'd have those opposites, wouldn't we? Okay, that's one thing we could do. There's going to be more than one option here. That's the good news. Some of you are going to take a different route, and it's okay. Right, and what would you maybe do?
I times by 3 to get the negative x up to -3.
Okay, so you're going to take the second equation times +3, because if you take the second equation times +3, we would have a -3 for A here and a +3 in the other one. That would create opposite A values, wouldn't it? Okay, that's another option. Okay, so those are probably the two better options. I mean, we could make it a whole lot more work for ourselves and do something else, but we're not going to complicate it. Well, since I'm suggesting that we're going to create opposite A values, I'm not saying your way's wrong, Trey. We're going to go with Brighton's way, though. We want to create opposite A values. So we're going to multiply that second equation by, what did Brighton say?
3.
3. We're going to multiply the second equation by 3, because that will create opposite A values. Okay, so let's take that second equation and write it down and multiply it by 3. Multiply each side of the equation, or every piece is another way to say it. Every piece of the equation by 3. We're renaming. So we have a new name for our second equation. And I just made a mistake here, so I'm going to correct that. I get -3x plus 9y equals 18. Agree with me?
Yes.
Okay. All in favor of the new name? Raise your hand. We want to have a bad name here for it. Okay, looking kind of popular. Okay, now which equation do we have to add that to?
First one does.
The first one. We renamed the second one, so we have to add it to the first equation. We don't have any choice here. So let's take our new named equation, write it down, add to it the first equation that did not get renamed,
solve for, what are we gonna be solving for?
Y.
Y, because the x's cancel. So we have 15y equals what? 30. Okay. And now I can move over and, because I wrote so big I used to follow my space, I'm going to divide both sides by what? What should I divide by? 15. And y equals 2. Now it says use either equation to solve for x. In other words, you get to pick which equation do you want to use to solve for x. Make a good choice. Now, I'm going to suggest today, you know what, how in the past I said you could use any of the equations, the new named one, or the two original, okay? I'm going to suggest don't use the new renamed one because we just created bigger numbers in it. Don't use that one. That's going to cause you more work. Go back to one of the original ones and say, which one do I want to put my y in for and solve for? I like the first one because it doesn't have any negatives. If you like the second one, you can use the second one. Just make sure you use it correctly, okay? I'm going to use the first one. And then I will have a dilemma. It's 12, take away 12 on the right side. What do? I put a 0 because 0 is legitimate. It's okay, isn't it? What do I do now? Divide both sides by 3. So what is my x value? X equals 0. Is that okay? If x equals 0? Is there ordered pair? What would our ordered pair answer be?
0, 2.
0, 2. Is there such a point on the graph? 0, 2? Why is this the point on the graph? What's true?
This is where it's going to use.
This is where it's going to intersect. What's it?
Line.
The line. Each of these equations has its own line, doesn't it? And they're going to intersect at 0, 2. We learned that we could solve that by graphing. We learned that we could solve it by substitution. And now we've learned we can solve it by the addition method, the elimination method. So any way we solve it, we should get this answer. This is the most efficient way to solve this one, is by addition. Okay? So did anybody use the other equation, by the way, to solve for, okay, x? Did you get the same answer? Should you get x equals 0? Should we? Yeah, there can only be, we only want that one. Okay, anybody have any questions about before we move on? So, let's go to the back side then. I kind of wish I hadn't done it, put anything there for us to think through. I kind of wish I would have left it so we could explore all the options. And we are going to explore all the options before we even pay any attention to this part right here. Would you just not zero in on that part right now? Just stay with me. Let's change this to add the opposite first of all. 3x plus negative 4y equals 7, and 2x plus negative 1y equals 3, right? And maybe what we'll do this time, so we don't have to write again and have all this stuff and wonder what we were doing. Let's underline our a values. We got a 3 and we got a 2. Are they opposites? It's our first question. Are they opposites? No. Are they the same? No. Okay. How about our b values? Negative 4, negative 1. Opposites?
Yes. No.
No. Same? No. Okay. So what do we have to do? We need to create opposites. We need to create opposites. So there's all kinds of ways we could create opposites in this one. I'm going to suggest there's 4 different ways. Give me one of them. Give me one of the ways, maybe. Oh, I probably better take that back, because I'm just going into tomorrow or, yeah, another day's notes. So Cameron, what do you think is one way?
Multiply the second by negative
Multiply the second equation times negative 4, why?
4. 4 positive 4.
Then we would create a positive 4. Okay, it kind of sounds like that's what I had right here, isn't it? What's the opposite of negative 4? Positive 4. So if we would multiply the second equation times negative 4, we'd end up with a positive 4y, wouldn't we? Anybody think there's another thing we could do? Just to rename, we only want to just rename one of the equations. Anybody wanted to try anything else? No, this is one that we could do other things, but then we would involve introducing fractions and everything else. So I was on base when I said that there are 4 different ways. This is really the only way right now that's going to be most efficient for you. So, right.
Can you times a number by both of them, like times the 3x by 2 and times the 2x by 3, and get 6 on both ends and make one of them negative?
Okay, but then, so then what we would want to do is if we're going to multiply one of them by a positive, then we would want to multiply the other one by a negative. So we could, and that's going to be the next thing we're going to do in these notes. So 3x could get multiplied by 2. The first equation could get multiplied by 2, and the second equation could get multiplied by negative 3, because then we'd have a positive 6 and a negative 6. And that's what's going to eventually happen here. For today, we only have to rename one of them, the types that you get. Okay, so let's go ahead and do that. Let's take negative 4 times the, which equation is it again we're doing? Second. Okay, this is the part that gets kind of tricky. You might mess up which one you should actually be multiplying by. Make sure you're really careful about that. And I'll show you how you can know whether you were, you did a good job of deciding. So, yes, Isaac.
Here, you forgot to read that negative 12.
Thank you. What is the opposite of, so we're multiplying by negative 4, aren't we? Yes. So this should be a negative 12 here now. Good catch for me. Thank you, Isaac. Okay, so now this equation will get added to the first equation, which after we changed it to add the opposite is 3x plus negative 4y equals 7. Now, before you add them together and just go crazy and start crossing out thinking that you did, make sure that you created opposites. This would be right here is where you want to say, did I even create the opposites I needed to? Because if I didn't, if both of them were positive 4y's, they're not opposites. Something went wrong. Okay, so we got to make sure we created the opposites before we cancel them out. Make sure they're opposites. Okay, go ahead and finish solving this. Get the ordered pair solution for this problem. And you get to pick which equation you're going to use to get the y value. Your first value you should solve for is the x. After you've solved for the x, pick the equation you like. And help you go back and solve for y. Oh, do I make a suggestion in your notes which one you do or not? No, I can pick. I'm trusting that you're working at. I got over here 1, -1. Anybody want to agree with me? Okay. So regardless of which equation you use to solve for the y, we should still all get the same y value, which is -1, right? And then we can write our ordered pair answer, ordered pair 1, -1. Okay, so today, keep in mind, you only have to rename one of them, even though we got off on a little bit of a path saying that you can rename, or we are going to eventually do that. You only need to rename one of them, but sometimes you may get to make a different choice than somebody else makes. You just have to make sure that you do what? What is our goal in renaming these equations? What are we trying to create? It's a one-word answer. What are we trying to create, class?
Opposite.
Opposites. We need to create opposites. Either they're opposite A values or they're opposite B values, but our goal has to be to create those opposites, or we're going to send ourselves down a path that's not going to help us much. Right.
So when we times both of them to get us different opposites, then would we still get the same answer that we just did?
Yeah.
And just using higher numbers?
Yep, you just would have been having to work harder. So if we would have done what you suggested in the beginning, we multiplied the top one by -2 or +2 and the bottom one by -3, you just would have renamed them, you still would have added them together. Then in that case you would have eliminated the x's, you would have been solving for the y first, you would have gotten the same answer, -1, and you'd have gone back and solved for x and gotten +1. Just would have been an extra step in there you didn't need to do. Okay, let's get started on your homework. Get out a sheet. Well, let's see. I say get out a sheet of loose leaf paper, but there is white space on here if you want to try and do it on the white space.